Since this chapter is about users and groups, it makes sense that we would start by creating users. So there's a series of related commands: user add, user mod, and user del. Luckily, those are fairly easy to pronounce. And as the names imply, they're used to create a user account, modify a user account, or perhaps delete a user account. Each one has slightly different ramifications. But let's begin by doing a creation. When you go to create a user account, we're going to see it's going to have to edit a particular file, which I'm going to pronounce as etc password. That's commonly referred to as the password file, but spelled on my PASSWD. Much like the command you use to change your own login password is spelled that way. Each line in that file is a user account, be you the root user, a normal user, or a service user. Not only will the line be created there when I install a user, it will also create it under the constraints of system-wide defaults. And this is in the file called login.defs. For example, what might be the lowest or highest user ID that I could farm out? Other things we can do is when the user gets created is where will their home directory be? The convention is /home followed by whatever the user's name is. And what happens is user add will pre-populate their home with the contents of what's called the skeleton directory, or etc. So when we talk about user profiles, you'll see that as an administrator, if I'm about to create a lot of users, it behooves me to set up etc, which is a template of what home directories would look like, then go through installing all my other users from the template. So the template of a user account is really a combination of etc, which are individual files, as well as being constrained by login.defs. But if you fix those two config files first, then all of the accounts you stamp out will come from the same template. So the only thing about a user account that this doesn't handle for us is, of course, the login password. We'll have to set that separately. So the user add command has got multiple options. As we'll see when we start doing it, I could do something as simple as this. I could just say user add Joe, and that would be fine. It would take all defaults. That would do everything except for give user Joe a password. But I might want to override some of the defaults. So it's simply more options that would be passed to user add. As an example, the default shell, as specified in etc login defs, is bash shell. Well, maybe user Joe has a strong Unix background and really wants a Korn shell. I can override the defaults by doing user add and applying the options. So let me just modify that one. And instead of just saying Joe, we'll have to say -s for shell. And the shell you get is bin ksh for user Joe. So you'll see these commands support options. What's different about these options is they have their own argument. So when I have the -c option, what follows the C is the comment value. When I have the S option, what follows the S is the shell to assign. So these particular options, they take their own arguments. At this point, user Joe has been created. It's still not usable by user Joe until we assign a default password, or I should say at least a starting password. So the root user is going to assign the first password for a user by doing this command. And in fact, the root user can also change anyone's password through that command. This is done when people are off the system. Forgetting passwords is a very common help desk kind of a thing. You simply assign them. There's no way for you to retrieve someone's previous one. You give them a new one. So this will be done after the original user add. Then after user Joe is logged in, he's free to change his own password, so long as he's within the constraints of what we call the password aging. We'll see that a little bit later in this topic. So this is an example of a user changing their own password. When you do it, the first thing you'll have to do is enter your own password. Then you'll have to enter your new password. You'll actually have to do it twice. Whenever you enter the passwords, they are not shown on the screen so that no one looking over your shoulder could see the clear text version. So you're asked to authenticate with the previous or current password, then you give the new password twice. Now, the passwords undergo what I like to call the triviality checks. So there are ways to enforce quality restrictions on a password. For example, could M. Anderson's password be ABC123? Could M. Anderson's password be M. Anderson? Things like that. So there are mechanisms to enforce quality of passwords. What you'll want to look for is a message that says the authentication tokens have been successfully updated. So when M. Anderson changes their own password, they will have to pass through the triviality checks. It turns out, as the root user, I could apply a poor quality password to M. Anderson. So I could give M. Anderson a password of ABC, but they could never change their own password to ABC. So the root user is free to break this rule. It's not a great idea. You should assign a high quality password. So let's take a look at where these things are stored, and then we'll jump online and try one. But this is the file that we call etc password. Again, each line describes one account. The lines are colon delimited, and there are always exactly 7 fields. In fact, it is so syntactically tight, that is why you positively should use user add, user mod, or user del to change this file. If you accidentally modified it by way of any other editor and left a typo in it, you could easily mess that file up where even no one could log in if you've messed it up badly enough. And if no one can log in, you're back to catastrophic recovery mode. Each line in the file has 7 fields delimited by colons. You can see the lines here left to right, the fields here left to right as delimited by colon. The first field is the username, and as we said, that maps to the user ID. So that's how your credentials are mapped to your name. Part of your other credentials would be your group ID. We'll do groups here shortly. What's known as your primary group. There are indeed secondary groups. When a user logs in, what do they expect? They expect a home directory, and they expect a login shell. So when the user logs in, they're placed to that directory and they're running that shell. What's funny about the password file is this. We actually do not store your login password inside that file. Way back in the ancient days of Unix, they did, but for security reasons, it's never stored in that file. You'll see the letter X in that field, and the password's actually stored in a separate file that is restricted. Only the sysadmin can look inside of that file. So we still call it by the historical name, but there are no passwords inside. That file is publicly readable. That's why we have to put the password somewhere else. And the place where we put it is a file called etc shadow. This file has what's known as a hash of your login password. So passwords are never stored in clear text. A hash is called a one-way cipher. Do not confuse hash with encrypt, decrypt. That's two-way. A hash is a one-way cipher, so that from clear text you can generate the hash, but it never works in reverse. So we don't store your clear text password, we store a hash of it. Secondly, we put it into a file that only root has access to. So we're going to store people's passwords there. It also has, as you can see, password aging information. So here's an example of the shadow file. And all of this that they've underlined in the slide, all of this is the hash of the root user's clear text password. Now, there are multiple hashing algorithms out there. It's all specified again in login desk which one is used. All the rest of the colon separated fields in the shadow file have to do with the password aging information. When was the password last changed? How long before you must change it again? We'll go through examples of setting password aging here shortly. But if you look through the remainder accounts that are listed on the slide, these are some of those service accounts. You'll notice the asterisk or star. Well, no matter what you type in clear text, the hashing algorithm would never generate only a single asterisk as a hash. So you'll always fail to authenticate as one of those users because it's impossible to have a hash that is just a star. This is how the accounts are kept open, right, but effectively unused. All right, let's go through a quick example and I'll create some user accounts for you. So currently I am logged in as the student 1 account. So to perform user add, I would of course have to either transition to the root account, but my best practices say we should do this through the sudo mechanism. So we'll try one there, sudo user add on M. Anderson. And as simple as that, we got no error message. It must have worked. What we can do is go take a look by maybe of the cat program, and we'll use cat to show us the end of etc password. And you can see I did that as student 1. That did not require privilege. And there's the M. Anderson account. You'll notice the default shell is bin bash, the home directory /home/M. Anderson. And by default, we just take the next higher UID and we increment it. So when I install additional people, there'll be 1,002, 1,003, etc. So let me go ahead and I'll do some additionals. This time we'll say sudo user add, and we'll add C. Mason, right? Again, taking advantage of the history mechanism. We'll add another user there, A. Riley. And we'll add another one there called R. Alexander. And lastly, we'll do one called R. Stanley. So now I have added 4 new user accounts after M. Anderson. Let me just use my up arrow to review the changes in the password file. And there they are, nice increments on the user ID. Now, these accounts have been created. However, they have not been passworded yet. Now, I would love to just show you the shadow file to indicate they have no hash of passwords. But as we said, this file cannot be viewed by the casual user. It requires super user privilege. Luckily, we can do sudo. So I'll just reuse this command with sudo in front. And sure enough, there are the new accounts down there at the bottom of the shadow file. And what they have as their password, we pronounce bang bang. So the short-term word for the exclamation point is called bang. So therefore we have bang bang in the password field. So no matter what someone typed in as a password, it would never hash out to be bang bang. So let me go ahead and create a password for one of these accounts. I'll say sudo password M. Anderson. Now, I am going to change and assign M. Anderson a new password. And you'll notice that it gave me a little caution that said your password was a little short. However, it does say authentication tokens updated successfully. I have now changed M. Anderson's password. And what I can do is just simply go back and look inside the shadow file. And sure enough, now M. Anderson has got a hash of the password right there. All the way through that colon right there. So we can repeat that for all the other users then. We're going to say password on C. Mason and give C. Mason a password. Password on A. Riley. Let's see, C. Mason, A. Riley, R. Alexander. And then we'll do the last one, which is going to be R. Stanley. Oops. So as you can see, I had to spell it the same way both times, so it won't allow mismatched passwords. Now, when you look inside the shadow file, all the accounts have passwords. And I actually assigned exactly the same password for my brain to remember them. But even though they all have exactly the same password in clear text, notice how each one is a different hash. So again, it increases the security. The clear text can hash out many thousands of different ways. Right. Now, the way to test the account is to actually use the user's account. So what I'll do is I will attempt to become one of the users. I can become M. Anderson. And I can do this by saying su-M Anderson. Now I'm running SU as student 01. I don't have privilege. I will have to authenticate as M. Anderson for this SU to work. So I'll try it out. And it looks like my prompt string changed. If I say, who am I? I'm M. Anderson. If I say PWD, I'm in M. Anderson's home. And if I do an ls-al, I can see all the things put out there into M. Anderson's home directory. Again, these were files that would be copied from etc skel, as well as anything else from login defs. But that's the idea for setting up user accounts. User add them, give them a password, and then just run through a quick check to verify that it works. But like any other account, when I am finished doing M. Anderson things, I should revert back to my own account. So there I'm back to being student 01. Let's go back to the notes and we'll talk about the change age command. So after an account has been created and then the password has been assigned, we can change parameters called the password aging parameters. The idea behind this is that passwords should be changed frequently, but not too frequently. Usually there's a minimum time you must keep a new password and a maximum time by which time you must change it. You'll also get what's called the warning that says if your password's about to expire, you have to go ahead and change the password. So as the administrator, I can control these things by using change age. So here's my change age command, and you can see with change age, there with an E, I'm setting what's called the drop dead date or expiry. User 1 better change their password before this date or their account will be locked. Or maybe here, I just want to see what the aging information is, change age-L. If you want to change instead of a drop dead expiry date, but rather a rolling window, here we're saying passwords must be changed every 90 days. Most organizations have policies that require passwords to be changed every 30, 45, maybe as much as 90 days, and it's a recurring thing as opposed to a single drop dead expiry date. That's used more often. Although if both are in there, whichever one occurs first would cause the account to be locked. The account is only locked. The root user could always unlock it. So change age is simply changing shadow parameters. User mod is how we can modify a user account. Again, we're just changing a line inside the etc password file. You can potentially change that comment field, right? You could actually do a change in their group membership. So it's kind of interesting that we're going to talk about groups next, and we're going to put people into groups. But later on, I might invent a new group to satisfy some new project. Well, I don't want to create additional user accounts just to map them to the new group. I want to take my existing users and put them in a group. So after the group has been created, it's actually a user mod command that changes a user's group membership. Now, we're going to cover group mod in a few moments. Group mod does not change membership list of groups. It changes things like the name of the group. You're really modifying the user account by putting them into a separate group. So here we're doing a user mod on user 1 and adding them to what's called the sales group. User mod with an L allows you to change the user's login name. If I do this, that means user 1 would now be known as user 99. Be aware if you make that change, you're probably going to have to rearrange the file system structure, because what used to be called /home/user1 now needs to be changed to /home/user99. So the user mod only changes the part inside of etc password, but the name of their directory on the file system will have to be renamed. It doesn't handle that for you. So there we do an MV. We'll cover in a bit is our renaming command. Rename it to the new name. Luckily, the user did not change their user ID, which is stored inside the file system's metadata. So we don't have to change any of that. We're just changing the name of a directory to match the login name. Locking a user account means it cannot be logged in. We can do this two different ways. Password -l, followed by the user, would put the lock on it. Password -u would unlock it. All this does is make a tiny change to the hash inside of Shadow and adds bang bang to the front of their hash. So that's effectively how you lock it. And then password -u simply unlocks it by removing the bang bang. You can also pull this off by doing user mod with an uppercase L, user mod with an uppercase U. Those wind up being synonymous. Again, this of course is administrative privilege to change by locking or unlocking someone's password. User del removes a user account. And what that would imply is that user can no longer log in. It would take their lines out of etc password and etc shadow. However, it doesn't delete their home directory unless we come with an extra option -r. Well, you do have a caution here about use caution before deleting accounts. It's not so much the user, it's the files and directories they may own. If you just blindly disable a user's account, then remove them with all their files and directories. We talked briefly about groups. There might be some files and directories that were shared and in use by other group members, and now everything is gone. So a better mechanism would be to disable the user account temporarily by locking it, discover what files and directories might be used by other users. You can deduce that through group membership. Change the ownership of those files and directories to some other user, then come back and do the user del. But we don't want to have to rely on some backup media because we deleted a user's home directory, but there were shared files and folders below it. That, of course, would be the ultimate backup, is just having to take it from the historic, from the archive. So better to disable it, wait and see if anything bubbles to the top, meaning problems arise, take care of reallocating the files to other users, then go ahead and delete the user and their entire directory. And once it's done, that user ID goes away and everything else goes away. Let's take a quick look at modifying a user account and then deleting it. So we see here we have an M. Anderson account has been created. M. Anderson has certain characteristics. Let me show you M. Anderson's entry inside the password file. All right, so there's the M. Anderson, and we can see there the name is M. Anderson, and they have the certain credentials and a certain home directory. Right? So I can change to perhaps a different shell. I could change to a different home directory. I could possibly even change their login name. So let me just try one like that. For example, I'll just say user mod, and I'll say change the login name to Mike Anderson for the M. Anderson account. And of course, can't do that because I'm still the student user. Can only be done through the sudo mechanism. So sudo user mod -L. We take a look in the password file. The name is now Mike Anderson, but the same numbers. But when I look at the parent directory, you can see there it's still set to /home/M. Anderson. So when I look in the directory /home, it gets kind of confusing because there's a guy named Mike Anderson, but the name of the directory is M. Anderson. So it's a little bit of messiness. It's a little bit of something that should be cleaned up. When you change someone's name, we should change the name of their home directory. I shouldn't rely on Mike Anderson doing this. So I'll just do it with the straight move command I mentioned earlier. I'll do a sudo and I'll just say move /home/M. Anderson to /home/Mike Anderson. We'll come back and take a look at the home directory structure. It looks correct. We'll come back and look at the password file. It all looks good. Oh, sorry, I guess it doesn't look good, does it? I didn't get that changed. All right. Looks like it's time for another user mod. So this time we do the user mod. We're going to change user Mike Anderson. But this time, I've got to change the name of their home directory to /home/Mike Anderson. All right. So my user's now called Mike Anderson. The file system says Mike Anderson. I just have to fix etc password to say Mike Anderson. Well, I got no complaints from sudo. Let's take a quick look. And there it is. Mike Anderson has the home directory Mike Anderson. Let's test it out. SU to the Mike Anderson account and give his password. That didn't change. Sure enough, there I am, and I can see all my stuff. Okay. Now, user del. If I want to remove user Mike Anderson, I have to use user del to do it properly. The question is, should I leave that home directory out there or not? I'll try it first of all by just saying, sudo user del Mike Anderson. And that should remove Mike Anderson from the etc password and the etc shadow file. And it did. However, when I take a look at the home directory, it's still there. A little funniness happened though. It no longer has a name tied to it. It only has a number. So this is good thinking for what's going to be occurring in a little later section. The numbers are actually stored in the file system infrastructure. It's the number that's really part of the metadata. When you do an ls-l and you see names, it's simply because they dereference the number back into a name. So if you see only a number, that indicates there is no matching name for 1001. We can verify that by looking inside the password file, and sure enough, the entry that had 1001 is gone. You can see the hole in between. So this is, again, a problem. I have a home directory out there, but nobody owns it. Maybe I should have just locked it, but it's too late now. Once they've been removed, they've already been removed. But this idea of a directory that has no owner is poor security. It's poor form. And any kind of security audit would find that. So we should either give those files to some other user or simply remove the directory. Well, it's too late to say user del-r because I've already deleted the user. I'll have to use the file system as the root user. So I'll just do an su with an rm-r on home Mike Anderson. And that would go back and have a look, and sure enough, it's gone. So again, use caution with the removal. If you don't do it all, there could be little artifacts left behind that either need to be dealt with, either get rid of them, or perhaps give them to some other user. But it's always bad form to leave anything not owned by an individual user. All right, so that's going to talked about then the creating, the modification, as well as the deletion of user accounts.